Hey there, students. It's your favorite math teacher in the entire known universe, and today we're going to be taking a look at Topic 7, Block 3 of Linear Patterns and Functions. Now, you're going to have to remember a little bit about what we did in Topic 7, Block 2, when we were spray painting towers made by cubes that were being stacked one on top of the other. And so let's take a look here. Page 219 in your book if you're there. If not, well, then you're following along in the OneNote and taking notes. All right. Whoa, let's move this back over here where it belongs. All right. Well, here we go. Now, let's take a look and see what we've got going on here. It says, here's a table that you completed using the Exploring Painting a Tower. Now, the first question it's asking us is, what stays the same in this table of values? Well, let's take a look at what stays the same. We'll highlight all the things that stay the same with a yellow highlighter. So let's take a look. Now, I notice in every one of these rows we have the top, the top, the top, the top, the top, and the top. And that top is represented by this 1 that we have in every one of these, right? And so we should probably at this point say, well, you know, that's part that stays the same. So let's have a look at that. All right. So first of all, we can see that each tower has a top face to be painted. And this is the 1 plus in the numerical representation where we see it here. Yeah, okay. Well, what else stays the same? Let's scroll up here and have another look and see what else we can find that is definitely staying the same. Let's see. Boy, I'm starting to see this. 4 cube faces per story. 4 cube faces per story. Every one of those has that. There are those 4 cube faces per every story that got painted. And that is the times 4, times 4, times 4, times 4, times 4 in our numerical representation. So that's another thing that stays the same. So we should definitely write down something about that. So we'll go down here and we'll get that typed in there. All right, well, we can see also that in addition to the top that stayed the same, each tower has 4 cube faces per story. This is the times 4 in the numerical representation, and you can see it in each one of those. Perfect. All right, well, question number 2 asks us, what changes in each of these? What is it that's changing in every one of these that's happening? Well, let's go up here and take a look, see, and we'll use a different color for what is changing. Let's use blue. All right. Well, I've noticed every one of these, it says, well, this one has 1 story, 2 stories, 3 stories, 4 stories, 5 stories, 6 stories, that matches with this number here. So the number of stories changes every time. So, well, let's indicate that down here in the spot where it says what changes. And as we can see, the number of stories in a tower changes from one tower to the next. Each tower has 1 story more than the one before it. Okay, perfect. Now, while we're at it, while we're getting into all this highlighting, since we've got the number of stories that changes marked in blue and the things that stay the same marked in yellow, let's take and mark the number of cube faces in green, because that changes every time also, but that's because that is our output. The number of stories is our input, and the number of cube faces is our output. So let's go down and see if we can answer the next question. Question 3. And it says, use the patterns in the table to write a function rule that expresses the relationship between the number of faces to be painted, which is the F. Also, that's our green. Okay, so if we want to, we can. The number of faces to be painted, that's our green, that's our F, and the number of stories in the tower, and the number of stories in our tower is represented by the blue. So we can use that. Okay, so let's think about that. Let's make a function that is indicated by this particular set of variables. So again, if we look at this here, that's our process, that's our function. So f, the number of faces to be painted, that's the green, the output, is equal to 1 plus the number of sides for the tower multiplied by 4. All right, but a better way to write that, that's more clean, more neat, more efficient, would be f is equal to, so the number of faces to be painted is equal to 1 plus, what is s times 4? Well, it's just 4s. That's our function, all right, that we found from this pattern. If you look, right, it's 1 plus 4 times the number of stories. 1 story, 2 story. Oh, and we better highlight those because that was also something that was changed. All right. Those were the numbers that were changing. So 1 plus the number of stories multiplied by 4. Perfect. All right. Well, let's move on to the next series of questions. And we're probably going to need this function rule again. F equals 1 plus 4 multiplied by the number of stories. Okay. So this asks us, how many cube faces will you paint on a tower with 50 stories? Well, we take that 50 and we substitute it in for s, right? So in this case, those would be, the number of faces would be equal to 1 plus 4 times 50. Okay, well, let's see. 4 times 50 is 200 plus the 1 equals the number of faces. And 1 plus 200, well, that's 201. So there will be 201 cube faces that we'll have to paint on a tower that has 50 stories. And we've just demonstrated how we know algebraically. So that's fantastic. Now I'm going to let you do number 5 on your own. If we have a tower that has 100 stories, I'll let you figure that one out. Make sure that you justify your answer algebraically or in words. But let's look at question number 6. Now I'm gonna rewrite my equation again. F, number of cube faces, equal to 1 plus 4 times the number of stories. This says, now suppose you only have enough paint to cover 81 cubes. 81 cube faces. Okay? What is the tallest tower that we can paint? So how many stories can our tower be if we only have enough paint to paint 81 cube faces? Well, this one changes things considerably because now, instead of knowing how many stories we've got, we know how many cube faces we have. So we can replace that for F. So 81 is the number of cube faces equals 1 plus 4 multiplied by S. Two-step equation, easy enough to solve. Subtract 1 from both sides. Right? That one and that one cancel each other out. We get 80 on this side equals 4 times S. And then we divide by 4. If my pen, there we go. Divide by 4. That 4 and that 4 cancel each other out because 4 divided by 4 is 1. 1 times S is just S. And 80 divided by 4 is 20. Now, that means that our tower will be 20 stories tall if we can only paint 81 cube faces. And how do we know for sure? Well, we know for sure because 81 is equal to 1 plus 4 times 20. Right? 4 times 20 is 80 plus 1 is 81. There you have it. There's your justification. Okay, so What about if there's only 125 cube faces that we can paint? Same deal. I'm going to let you do that one on your own. And then this last one, what if you only have enough to cover 32 cube faces? What is the tallest tower that you can paint? Remember, you can't have part of a story, okay? It has to be full stories. So how many stories tall will it be if you can only paint 32 cube faces? I'm going to let you do that one on your own also. And then after you've completed this, you'll go and you'll finish up your forms document where you'll find a few more questions to help solidify this skill for you. All right. Have a great rest of your day. Don't forget to be awesome and good mathing.